All right, here we go. We have ourselves 5.3. This is a big one. This is finding inverses. All right. Love the way they teach this. We learned two ways. Okay, we learned the algebraic way, and a lot of us are algebraic minded and we like algebra. And then they showed us this glorious visual way. A lot of us are visual people. Okay, and I love the visual way. I've never seen that before. Before it was like, okay, algebra, or I don't know what to tell you. Okay, so here's the first thing I would say to you about inverses. When they're super simple equations like these, a lot of times the inverse can be predictable. Because what we saw in class was, if you look at a function and you look at its inverse, you see a lot of opposite operations. For example, if the function has a 3 times x, you will see that the inverse has a 3 divided by x, okay? So this is a right here. If your function has an x cubed, you'll see that the inverse has a cube root of x, okay? Because these are opposite operations. So this one is B. Now let's look at these double ones. This one had a 2 times, but it also had a cube. So we should see a divided by 2, and we should see a cube root. And it's this guy right here. And do you see what I meant by when it gets more complicated, it's less predictable? So I find it a little unpredictable that the 2 was outside of the cube here. However, in the inverse, the 2 is with the cube root. All right. So as soon as the function stops being this simple, I don't want you to guess anymore. After that, we rely on either the algebraic method or the visual method that they're going to show us. I only want you to do it that way. This only because it's matching and I can tell based on the choices here, I feel confident. Otherwise, I would work it out. Okay. Okay, now let's look at this last one. This one has a divided by 2, so I should see a times 2 in the answer. And then it has a cube, so I should still see a cube root. And when I look, this is the one that has a times 2 and a cube root. So it has to be D. But again, a little bit weird that the 2 was in here with the cube, and over here it's outside of the cube root. Don't guess, okay? We're going to do the math out and see. Okay, here we go. Okay, this is so perfect. We are going to do this both the algebraic way and the visual way. The first way I'm going to do it is the visual way, because number 2 kind of sets me up for that. But then after I do it the visual way, I'm going to do the same problem the algebraic way, because I want you guys to be able to see which one works better for you and do that way. Okay, the first thing they want is for me to complete this table to build this function, which means looking at the function, I'm going to use PEMDAS, or I'm just going to look with my eyes at where x is and what's happening to it first and go step by step, okay? Let me see. I got the idea right now to erase all this and this. Okay, so I have enough space to finish this problem out this way. Okay, so looking at the x, which is what I started with, the first thing that happens to x in my equation is that it goes minus 2. And if you use PEMDAS, PEMDAS would tell you, look inside the parentheses, and you would see, okay, minus 2. So this x went whoop, minus 2, okay? And it became x minus 2. You're going to take the previous step, which you had, and then do this to it. That's it. Now, after that x minus 2, what's happening to the x minus 2? And that's this guy, which PEMDAS would have told us the exponent, okay? So after that, whoop, what's happening is we're getting cubed, okay? which means I got to take my previous step, throw it in parentheses, and cube it. All right? And now let's see what's happening next. Now, what's happening to the x minus 2 cubed? It's getting multiplied by 2. All right? You might say plus 2, but don't forget, PEMDAS tells us the multiplication counts first. Okay? So now we're getting times 2. So I'm going to copy down my previous step and then just multiply it by 2. Okay? And the final thing happening to it is the plus 2 right here, the addition subtraction at the end of PEMDAS. So we're getting a plus 2 at the end, and then we get our previous step with the plus 2. Oh no, it got cut off, but that's okay. There you go. Okay, fantastic. So now here we are. What I want to do, it said build the function out for number 2, so this is what they meant. Now that we've done this, I want to finish this visual method of Desmos to get the inverse right here, okay? And here's how it goes, you guys. They make it so easy to see. You're just going to copy the box down underneath it. And you're going to start with x over here and work your way that way to get the inverse, okay? And so you're going to do your this thing, and you're going to figure out what operation you need to do, but it's not that hard to figure out what to do first. All you got to do is look above and do the opposite. So plus 2, the opposite is minus 2. And now you do what we did before. Take the previous step of x and just go minus 2. And now we're going to keep undoing it by taking the previous step of x minus 2 and doing the opposite of multiplying by 2. So the opposite of multiplying by 2 is dividing by 2. So I'm going to take the x minus 2. And the way that we divide by 2, you guys, is we put everything over that 2. Okay? And now I have to do the opposite of the cube. And the opposite of the cube is a cube root, which means I take everything from my previous step, the x minus 2 over 2, and I put it all inside of a cube root. Okay? And finally, from here to here, I did minus 2. To undo the minus 2, I must do plus 2. So I take everything I had in the previous step, which is the cube root of x minus 2 over 2, and now I just do plus 2. And this, you guys, is the inverse, okay? Which we write as f inverse of x, all right? It looks complicated. It looks like there's an exponent that's -1. Technically, it's not. Technically, it's a notation that lets us know this is the inverse of f of x given in that problem. Okay, let's go find it. A big cube root with an x minus 2 over 2, and it has plus 2. This is our guy, C. Okay? So this was the visual way to do it. As promised, let's do this algebraically. Algebraically, we will take our f of x equals blah, 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 blah. I'm going to rewrite it, though, as y equals 2 times x minus 2 cubed plus 2 instead of f of x. And then what we do to find the inverse, we want a function that's undone this, all right? But I still want y and x. So what I do is I switch the x and y. And we're going to see in the next section what this switching of the x and y, what other places x and y switches, which is pretty fun. Boop, boop, boop. There we go. Switch the x and y, and now isolate y. Okay, what do we get here? We got to isolate the y. So you got to start undoing this formula to get to y. So we have to first get rid of that 2 by going -2, -2. So we get x minus 2 equals 2 times y minus 2 cubed. Man, that's a lot of 2's. And then we divide both sides by that 2. You can't distribute it because of the cube, and you wouldn't even want to. We want to divide it away. So then these cancel, and you get x minus 2 over 2 equals y minus 2 cubed. Now we undo the cube by doing a cube root to both sides. Question for you. When we cube root both sides, do we need a plus or minus? The answer to that is no, okay? The reason we get a plus or minus when we square root is because there are two answers, a positive 2 and a negative 2, that when squared give us a positive 4. However, with a cube root, that doesn't happen, all right? Only a positive 2 times itself 3 times will give me a positive 8, okay? A negative 2 times a negative 2 times a negative 2 would have given me a negative 8. So there aren't two different numbers that when cubed give us that number. So that's why there's no plus or minus with the cube, but there is a plus or minus with the square. So odd and even is the key. If it's an odd root, you do not need that plus or minus. Okay, let's keep going. Boop, boop. Y minus 2 equals just a cube root with no plus or minus of x minus 2 over 2. And last thing, we add the 2. And we get that y equals the cube root of x minus 2 over 2. And then what I would do, oh wait, what? Forgot the plus 2. And then what I would do is at this point, instead of y, I would say f inverse of x equals this, okay? Same answer, just different ways, all right? You can follow this, match it to what we did here, and see that we did exactly what we did here in the exact same order. We first subtracted 2, then we divided 2, then we cube rooted, then we added 2, okay? However, it's easier for some people to see it here, and it's easier for some people to see the correct order and what to do here. So that's a decision you're going to have to make of which way works for you, okay? I'll do my best to solve these in a balanced way, do a little bit of all the methods. Okay, here are some functions and 3 operations used to define each one. Write the function and their inverses. So they're not really giving us the function. They're having us build it, but telling us what to do. So they're saying start with x, multiply by 4. Okay. Then they're saying take the 4x, subtract 1. Like this, you guys. Don't go trying to change this to be 3 or something. All you do is you take your previous step and you do what they said. And now they're saying take the previous step and cube it. Okay? And now we come over here. G of x is this 4x minus 1 cubed. And now they want to know what G inverse is. So I wish they gave me enough room to do it right under there, but they don't. That's okay. We'll just start with x here, and we will undo the operation. So the first thing we must undo is the cube. So the first thing we must do is cube root. Then the second thing we did was subtract 1, so we add 1. And then the third thing we did was multiply by 4, so we must divide by 4. I don't know how you want to do this division, guys. You could put a division symbol, or you can make it look like you're putting it over 4, because that's what we're actually going to do. That's the inverse. The cube root of x by itself, then plus 1 on the outside, then divided by 4 on everything. So do you see how every opposite operation's there? 4 times 4 divided by minus 1 plus 1, cube root. But was it super predictable how it was going to present? I would say no, it was not. So that's why I always like to do it out. Okay, let's look at this next one. I'll do this one algebraically, maybe, to be fair. Okay, first thing, they want me to divide x by 7, so x over 7. Then they want me to take the 5th root, so 5th root of x over 7. Then they want me to subtract 8. Okay, so the 5th root of x over 7 minus 8. All right, now to undo it, if you like this way, do it. Please, please, please draw it and take the opposite of these and work backwards and do it and compare and see if you get the same answer as me. I'm going to do it algebraically. So h of x is the 5th root of x over 7 minus 8. To get the inverse, I have to switch x and y. So I have to say that x equals the 5th root of y over 7 minus 8. And then I got to solve for y. So step 1, I must add the 8. Oh, look at that. And I get x plus 8 equals the 5th root of y over 7. Next, I got to undo the 5th root, because that's the thing most in my way. So I take both sides to the 5th power. And then these cancel. And then I have y over 7 equals x plus 8 over 5. And to undo a divided by 7, I will multiply by 7. Cancel it out. That means that h inverse of x is 7 times x plus 8 to the 5th power. Same thing you should have gotten the other way. Okay, let's go. Let's go do some more stuff. Let's do a visual one and an algebraic one, okay? This one. Write the inverse. I'm trying to decide whether to do this one algebraically or this one visually. I kind of want to do this one visually, you guys. Part of me thinks we should. So I'm going to make the box. Okay, actually, let's make it really big. We have space on this side. I'm going to start with x right here. And then the first thing happening to this x right now is multiplying it by a 4th. And I get 1/4 x. And then the next thing that happens is they go minus 2. So it's 1/4 x minus 2. Okay? Okay, now I want to go backwards and get the inverse. So I'll start with x on the bottom, and I will do the opposite of that first. So plus 2 to get x plus 2. And now from here, you guys, this was times a 4th. So maybe we're thinking we should divide 1/4. I would recommend right here that you fix this. When you're dividing by a fraction, go ahead and do keep, change, flip, if you remember. What happens is you keep the thing that you're multiplying, which in this case is our x plus 2. We're going to keep that. We're going to change the division to be multiplication. And then we're going to flip the 1/4 to be 4/1. So dividing by 1/4, you guys, is the same as multiplying by 4/1. And multiplying by 4/1 is the same thing as multiplying by 4. So if it were me, I would think of this as just multiplying by 4. And it's easier to kind of fix it right here instead of trying to take the x plus 2 and divide it by a fourth and then try to figure out what that means. Okay, so if you get divided by a fraction, please change and flip. Okay, and then do that. Okay, and now here we are. F inverse of x is 4 times x plus 2. It's perfect. Okay, let's go over here to number 7, which I will solve algebraically. We'll switch the x and y. X equals negative y cubed plus 11. First thing I must do is subtract the 11. X minus 11 equals negative y cubed. The next thing in the way, subtracted the 11. The next thing in the way is that negative 1. So we'll divide it, or technically multiply it. I mean, when it's a negative 1, dividing or multiplying is the same thing, just like a positive 1 is. So here these cancel, and I have y cubed equals, and then over here I have all of this over negative 1, which is the same as negative 1 times it, okay? And then finally cube root both sides. So I end up with that the inverse is the cube root of negative x minus 11. Okay? Let's keep going. This one's a little more complicated. This one's a little simpler. I'll do this algebraically and this with the visual. All right, here we go. Algebraically, this one. Let's say x equals 1/2 the cube root of y plus 1. So the first thing I have to do is get rid of that 1/2. And instead of dividing by a half, I can multiply by 2, okay? Just like over here. So here it is, we're looking at it algebraically. We'll multiply both sides by 2 to get 2x equals the cube root of y plus 1. And then we will just cube both sides to get 2x cubed equals y plus 1. And now just minus 1 on both sides. So we get 2x cubed minus 1. Okay, and then over here, let's do this chart. Okay, we start with x. Then the first thing they do is to the x, the first thing they do to it is multiply by negative 1. The second thing they do is go minus 4. The third thing they do is fifth root it. And the last thing they do is multiply it by 3. Okay. So now let's do it. We're going to start with x over here and start undoing. So multiply by 3, we'll divide by 3 to get x over 3. Then we'll undo the fifth root by taking this to the fifth power. And then we'll undo the minus 4 by doing plus 4. Oh, that was supposed to be a 12, not a sink. Okay, and that's supposed to be a sink. Okay, here we go. X over 3 to the fifth plus 4. All right, and then the final thing is to divide by a -1, but please remember that dividing by a -1 is the same as multiplying by a -1. Yeah, there's not going to be enough space to write that. So it's going to be all of what I have here, which is the x over the 3 to the 5th plus the 4, all of this times a -1. Okay, so I don't even have to write the 1. I can just put the negative there. Yeah, multiplying by -1 and dividing by -1 are interchangeable, all right? Okay, that's the inverse. Oh, I forgot. This was so long. I forgot what I was even doing. So this is a negative x over 3 to the 5th plus 4. Close it up. That's it. That's the inverse of that one. All these answers should have been the same, regardless of what method you chose. Okay, now we're graphing. I'll do it. Let's do it. This is a quadratic, which means the graph is a parabola, which means that it will start out at 0, 0, and 1, 1, and -1, 1, and 2 squared is 4. So -4. If you remember our good old friend, the parabola, you guys, it's not a coincidence. When they bring these up in the spiral review, it's because it's going to become important in the next lesson. So please, please, please use it as an opportunity to refresh your memory. This is just a plain old parent function, y equals x squared parabola, okay? What we are looking at here is that, but we have moved to the right. Remember, x is a liar. We have moved to the right 3 and up 1. So we just got to pick this guy up right here and go to the right 1, 2, 3, and up 1, and put our new vertex right there. And all the points go right 3, up 1 to make this guy. This is this. The blue one is. Okay? The cube one, this is a cubic function. You might want to make a little table. I don't know how much time we spent looking at the cubic function, but the normal plain y equals x cubed one, when x is 0, y is 0. When x is 1, y is 1. When x is -1, y is -1. So it goes like this, like this, like this. It looks like a line. But if we plug in 2, 2 cubed is 8. So suddenly at 2, it has shot up all the way down to here. And if we put -2 in, we get -8. So at -2, it's shot all the way down to -8. And this should look familiar because we have seen this graph, though I don't think we ever graphed it ourselves with this much detail. It gives you this sort of a shape, which I know we did. We did polynomials extensively. Now, we have this, except it's moved to the left 1 because x is a liar, and down 2 because y doesn't lie. So we just move all these points left 1, down 2. Move this one left 1, down 2. Move this one left 1, down 2. Move this one left 1, down 2. And this one left 1, down 2. Everybody, left 1, down 2. And connected. There it is. Whew, that was fun. Also super long. So bye guys, I gotta go, I got stuff to do.